Some good news for anyone using FFmpeg or an application that uses FFmpeg in the background. As of January 3rd, 2024, we get the decoding of the new H.266 or VVC codec, which stands for Versatile Video Codec, if I'm correct. Yes, Versatile Video Coding. And this is the next logical step in the progression of the H codecs. So we started with actually started way back, but I'm going to start with H.264, which then improved with H.265 or HEVC. And now we're in the progress of turning over to H.266. So just like going from 264 to 265, the complexity increased. And with more complexity means that we have a more efficient video. We can have the same video, let's say at 10 megabits per second, and have a higher quality than that of H.264. Or we can have the same quality as H.264 at a lower bit rate. So that's even going to improve one generation higher, going to 266. But at this point, if we look, there's not too much information on it. There's a handful of chips that support hardware decoding of this new codec. One from Allegro, 3 from MediaTek, 1 from Realtek, and 2 from VeriSilicon. And this is coming from the VVC Wikipedia page. Now, the interesting thing about these chips is, especially from MediaTek, Allegro, and VeriSilicon, they actually support decoding of 8K up to 120 frames per second. So seriously at the bleeding edge at this point. And those chips are more for TVs because that's what they're going to be used for at first. And 8K TVs have come down a ton in price. You can get one right now, January 26, 2024, in the US for only $1,500 on sale at 65-inch. Not OLED, still LED, but a damn good price. Now, this implementation is being done through the libav codec library, which is implemented in FFmpeg. And if you're like me, I use the FFmpeg collection of libraries through the Handbrake GUI interface. So that's something to be looking forward to. But at this point, since there's no hardware decoding from Intel, NVIDIA, AMD, or Apple, that means everything has to be done through the CPU, through software decoding and encoding, and that uses a ton of energy. Now that, for example, AV1 through the SVT coding has become very efficient, you can get with an M3 chip, for example, 8K at a preset of 8, encoding at around 5 frames per second, where only, half a year ago, it was encoding at like 0.01 of a frame, which was really unusable because it would just be such a waste of energy at that point. So I'd be looking forward to who will be the first chip company to implement hardware and software decoding of H.266 within their desktop or phone or laptop chip.